Hello students, a warm welcome to Eduauraa. I am Nabanita Ghosh, your maths expert. There may be some objects which show symmetry despite the absence of the line of symmetry. Such symmetrical objects show rotational symmetry, about which we are going to learn. If any object follows rotation in a direction opposite to clock's movement, then such rotation is termed as anti-clockwise rotation. Other common examples of rotation are blades of ceiling fan and wheels of a bicycle. Rotational symmetry is also known as radial symmetry. While rotating around a fixed axis, if appearance of size and shape of an object does not change, then the object is supposed to be rotationally symmetrical. The recycling icon is also an example of rotational symmetry. Have you ever noticed something peculiar about the recycling icon? Look at this. You look at it from any direction or orientation, the shape is unchanged. This is what rotational symmetry does to the figure. In rotational symmetry, despite the circular movement, the shape and size of the object or the figure look the same. In the recycling icon, the arrows of the icon appear to be circularly moving, which suggests the rotational concept of recycling. When this icon is rotated through an angle of 120 degrees, it will look the same. A figure has rotational symmetry if it can be rotated by an angle between 0 degree and 360 degree so that the image coincides with the pre-image. The angle of rotational symmetry is the smallest angle for which the figure can be rotated to coincide with itself. So how can we define it? The order of symmetry is the number of times the figure coincides with itself as it rotates through 360 degree. Let's take an example to clear the picture. A regular hexagon has rotational symmetry. The angle of rotation is 60 degree and the order of rotational symmetry is 6. So, for 6 times it will come to its original position while rotating through 360 degree. A scalene triangle does not have rotational symmetry. Did you play a paper windmill? Its shape is quite interesting, right? It is a nice example of rotational symmetry. Now let's consider a paper windmill to understand the attributes of rotational symmetry in a better way. A paper windmill is the most joyous toy for every child. Its rotational movement amazes every child, but its unchanged appearance despite continuous rotation adds to the whole amazement. A paper windmill is a perfect example of rotational symmetry. Notice the movement of a windmill. When we forcefully rotate a windmill through an angle of 90 degree, then we see despite the movement there is no change in the appearance. On further movement, the shape of the windmill is the same as its original. The angles at which this paper mill is turned is called the angle of rotation. Here, the angle of turn is 90 degree. A full turn of rotation measures 360 degree. So, for taking one full turn, our paper windmill is moved 4 times. The reason for this is that the paper windmill shows rotational symmetry. The number of turns given to an object to come back to its original position gives the order of rotational symmetry, which is in this case is 4. So the order of symmetry is 4. When an object rotates about an axis, if on every turn, no matter what the angle, the shape of the object looks like its original, then the object shows radial symmetry or rotational symmetry. We must remember a few points related to rotational symmetry. What are they? The center of rotation is the center of the object. Number 2, the angle of turn depends on the shape of the object. Number 3, whatever the angle of the turn for a full rotation is of 360 degree. Number 4, the order of rotation shall be the number of turns taken to complete one full turn. Let us see the rotational symmetry in some common shape. The triangle has an order of rotational symmetry of 3, but we have to take an equilateral triangle. You are aware of the swastik symbol? It has an order of symmetry of 4. The roundabout road sign has an order of symmetry of 3.